In the summer of 2018, if you would book a flight with British Airways, all your data was siphoned onto a server that pretended to be British Airways. An attacker logged in with contractor's stolen password and changed a few lines of JavaScript to skim all booking details, including credit card information. And this went on for weeks, ending up in a massive data leak. And why am I telling this story? It was actually one of the first large GDPR cases. And remarkably, the fine that they got, a huge fine, which was X amount of euros, I don't remember it. The fine they got was not really due to non-compliance or lack of legal basis for data processing. The fine they got was due to lack of sufficient technical and organizational measures to ensure information security. Insufficient technical and organizational measures to ensure information security is the number 3 cause for the GDPR fines. The first one being non-compliance and the second one is insufficient legal basis for data processing. The key difference with the GDPR is not in the specifics of the CRA, where they are arguably more clear on what these necessary technical and organizational measures have to be. But the main difference is that CRA requires way more proactive approach. It's clear on that this is no longer a one and done thing. And most of GDPR security issue related fines were always after a breach. Under the CRA, that is clearly no longer a thing. You have to implement and be able to demonstrate continuous approach to security. And in this podcast episode, we will dive deep into the specifics of CRA requirements, what good looks like for each of those requirements. So strap in and let's dive into it. Hi, my name is Aram and I have been in application security for the past roughly 2 decades, and I will be the security technical expert throughout this podcast series. And I have my legal counterpart Lara with me.
Hey everybody, Lara here, the legal expert.
Could you please give us an elevator pitch of the CRA and briefly recap what we have talked about so far?
Of course. So in the last episodes, we talked about the CRA broadly, and the essence, the basic conclusion is with the CRA, cybersecurity cannot be an afterthought. So you have to take cybersecurity into consideration throughout a software or a product's whole life cycle. So from design to sunsetting even. Unfortunately, at this point in time, we don't have a lot of clarity on what the requirements are. We have 1 or 2 pages in the Act. We have a few draft guidelines and a few draft standards. Even though we know the dates of applicability, from September onwards, you have reporting obligations that become applicable. So vulnerability reporting and incident reporting. And from December next year, the CRA becomes fully applicable. But even then, things are not clear. So we took a deep dive into the CRA and distilled it into a framework that we think it's defensible, both from a technical and a legal perspective. We added some quality criteria to each of these components that you see. If you fulfill the quality criteria that is added to each of these components, you're as close as you can get to compliance, at least from where we stand. In the last episode, we talk about risk assessment, and the main conclusion is if you don't do a proper risk assessment, taking the user's perspective into account on a risk assessment, you cannot comply with the CRA. And now we're going to focus on this episode on the technical requirements, and I'll hand it off to Aram to talk a bit about them.
Thank you, Lara. And then, in this episode, we're going to focus mainly on what do you need to do from technical security perspective to get to compliance, or as close to compliance. My focus throughout the rest of the episode is very much in the domain of real security. If you know me, I don't really care about compliance. My philosophy is that compliance should be a bonus coming from real security. So the rest of the episode will be pretty much focused on real security. And then luckily, that actually also covers many aspects of the CRA. In any case, security requirements, architecture, design, and configuration hardening are coming largely from part 1 of Annex 1 of the CRA, and then third-party dependencies and requirements testing are mentioned explicitly in part 2 of the Annex 1 of the CRA. So we have 5 topics in the technical requirements, and some of these are relatively well understood and nobody's going to be surprised. And if I ask 5 people, what does it mean? Everybody will come up with a pretty much good answer. These are third-party dependencies and configuration hardening. Organizations typically have a pretty good idea what they should be doing there. There are a lot of tools to help you out with these topics. But of course, that is not the full story, and I'll tell you more about it later on. Architecture design is something that you have to be very deliberate about, but honestly, in terms of complexity and perhaps time investment, this isn't something I would worry about too much. Finally, security requirements and requirements testing are perhaps the least well understood topic in product development and software engineering. I've rarely seen a team that can correctly answer the question, what is a security requirement? The good news is that we have excellent resources to go with. Requirements testing, on the other hand, is something that is just an extension of the topic of security requirements. And by the way, AI can help you a lot with these topics. I would like to revisit our running example, the smart fridge. We have a smart fridge with a freezer compartment and a fridge compartment. And the freezer compartment, you can control it remotely with a mobile app and set the temperature of the freezing temperature. You can increase it and decrease it. And then you have a fridge compartment where you can pull in an inventory and perhaps get a notification if some products are coming close to their expiration date. Sort of a couple of interesting use cases, and then to position the topics and to show you the depth of the topics that you need to comply with from a CRA perspective. And then you would definitely need these topics to claim that you have security or some level of security. The first topic was security requirements, and as I mentioned, these are rarely well understood. But this is actually the starting point of your security by design. So actually the buzzword security by design, we think of it as, hey, it's part of the design, but it's not part of the design because it's part of your security requirements. And then what are security requirements? To answer that question, let's revisit briefly what is security. And security is typically agreed to be the triad confidentiality, integrity, and availability. Confidentiality means that unauthorized users should not be able to access data. Integrity is about unauthorized users not being able to modify any data. And then availability is that your data is available when you need it. And for your smart fridge, security requirements are sort of high-level specification to ensure CIA. And if you think about the functional requirement, we want to set the temperature remotely from our mobile app. A security requirement immediately would be that only the owner of that fridge or the person that is authenticated to be the owner of that fridge can do that. Coming up with these security requirements is a little bit of an art on its own. Just saying, hey, it needs to be secure or you need to preserve CIA, confidentiality, integrity, availability is not going to help much. Requirements have to be smart, specific, measurable, actionable, relevant, and time-bound. And here are a couple of security requirements to help you understand what I'm talking about. For the smart fridge cloud communication, we want the communication protocol to leverage mutual TLS, which means they have to be authenticated against each other so that the fridge knows it's talking to the right cloud and the cloud knows that it's talking to the right fridge. Even that requirement is not sufficiently smart, and to sort of decompose it into more specific and more actionable requirements, we're going to say that each fridge has a unique certificate provision at deploy time, which is stored in a secure storage so that you don't copy the fridge's internal representations and you can create unlimited number of fridges. And there is also no unauthenticated fallback mechanism. So if your fridge cannot talk to the cloud for any reason, it's not going to fall back to a less secure protocol, that it still uses that mutual TLS. It sounds rather complicated, and it actually is, but the good news is that OWASP is there to help you out. You're going to stand on the shoulders of the giants, and OWASP has already come up with a number of standards, guidance, resources that can help you select security requirements. More specifically, OWASP ASVS and mobile ASVS and cheat sheet series can definitely help you come up with a number of meaningful security requirements even in the domain of IoT or in the domain of smart fridges, although these requirements standards are from the domain of web applications and mobile applications. On top of that, Senelec will probably help as well once their horizontal and vertical standards come up. Senelec is in charge of creating horizontal or vertical standards for the CRA. They will publish many specific security requirements that you can distill from these standards. That is, at least to what I understand, is the idea of these standards.
Yeah, there's another entity called Etsy. It's the main entity doing the vertical standards, so the one specific for some types of products, and then Senelec doing the horizontal standards for the default products. So everybody basically falls into that category and will be able to rely on these standards.
And then finally, threat modeling, which we talked about in the last episode, is a great place to fish for security requirements. And threat modeling is a technical risk analysis method where you focus on what can go wrong. And by doing that, you will select your security requirements in a more natural way. Here is an example that demonstrates the power of threat modeling. And just to give you an interesting anecdote, it also illustrates the conflict between security requirements and business, and where things can go very well together. For a very long time, Netflix did not have too many requirements when it comes to selecting your passwords. You know that when you're selecting passwords, you typically have to use all these exotic characters, and it takes forever to manually create a password. And luckily, there are password managers to help you out, and I would highly recommend you to use one. In Netflix, up until some time, I think they are changing this. I'm pretty sure they're changing this now. Passwords could have been 6 characters long, which is a horrible idea from a security perspective, because they actually wanted you to share the passwords in the first place, because that expands their usage, that expands their business. It's not because Netflix isn't very knowledgeable in security. On the contrary, they are pretty strong in terms of security. They have created Chaos Monkey, which is something that you would consider using only if you have literally nothing else left to do in the domain of application security. Sharing passwords was their way of making sure that users can easily share passwords. And then after some time, now they are trying to prevent that, which means people who have already shared that passwords, everybody's now hooked in on the whole thing, and they actually want to use Netflix. Related to that topic of creating security requirements to shape the security of your product is requirements testing. And again, this is something that is explicitly mentioned in the CRA. The idea is that if you have the security requirements, you need to validate them that you did the right things right. And this is where the testing part comes in. And testing can be done by your QA team, so they can test manually for specific requirements. But a better idea would be to have this automated at the level of the code, so that every time you change anything in terms of your functionality, you can rerun the same tests and make sure there are no regressions, especially in terms of security. And as I've mentioned, AI can help you a lot by, first of all, it can just verify the security requirements, they are correctly implemented, but it can also help you write test cases for the security requirements. Here is a simple example from actually our SAMI tool. And then the security requirement in this case is verifying that user set passwords that are at least 12 characters in length. Any type of password composition can be used, which means you don't have to worry about uppercase, lowercase, digits, and special characters. In fact, any password can be chosen. And then finally, passwords are checked against an available set of breached passwords. By the way, these requirements are coming from OWASP ASVS standard. They are also pretty much in conformance with NIST standards. So this is best practice. You're probably shocked at this point, but yes, best practice says that you should not enforce any password composition rules. You only need to check it against an available set of breached passwords. This is what the implementation of testing for these passwords look like. If you are not familiar with coding, this might look like gibberish, but essentially it is a set of assertions that runs against the code base and tries to set variety of passwords and make sure that the code implementation is conforming with the security requirements that are presented. For instance, if we look at the first line, it says reject passwords of 11 characters. So clearly we want a password at least of 12 characters. And then the second line says, accept exactly 12 characters and there is a test. And the first one is expected to fail. The second one is expected to pass. And then these tests are running every time the software is built and the software is changed. Lara, does it make sense? Do you understand what I'm talking about here?
The second part of the image makes more sense than the first one, but yes.
Well, the first one is the actual test. This is the code, sort of. The second one is a list of, here is my input, what do I expect on the output? So if you have a calculator, 2 plus 2 is equal 4, and then you have a lot of these potential combinations, and then you check them against the result. Of course, you cannot do the all full possible space, but then typically we have some heuristics to what type of test data shall we choose to make sure that our code is 100% tested. That's the best I can do given the time frame as an explanation. Now, moving on, I've said this time and time again, you cannot code your way out of a bad design. And then architecture is a central topic in the CRA as well. It is a complex topic, but just as it comes to building a house, you're not going to reinvent the wheel. You can use the Roman arc. You can, if you're designing a bridge, you're going to use some best practices. So if you're focusing on architecture, what you are going to do in any case is a sort of mix and match of what you have in terms of architectural patterns to come up with a solid architecture. And when it comes to security here, what is important is that you pick security design principles and that you're familiar with these security design principles. Just to give you some idea of what these are, think of defense in depth, least privilege, economy of mechanism, no secret sauce, zero trust. Here is an example to illustrate you what we mean by design principles on our smart fridge. And in this case, we are looking at mobile app controlling the freezer compartment temperature. The mobile app is typically going to send a command to the cloud. And then at the cloud level, we have picked a pattern or a component which is called message queue telemetry transport, which is a standard protocol, a standard pattern, architectural pattern for IoT communication. And in this case, we are realizing the principle, economy of mechanism, and no secret sauce, because it is a very lightweight communication protocol, and no secret sauce means we're going to use something reusable. We're not going to come up with something very secretive from our own end. This MQTT protocol is going to send that command to the fridge. Actually, the fridge is going to poll it and then it's going to get it back. The specifics are not as important right now. And once the fridge receives that command, first of all, it's going to validate the signature to make sure that it is our trusted cloud that is sending out that command, that it is not a rogue cloud, for instance. And then, and this one is probably the easiest to understand for everyone, it's going to check the range. It's going to check whether the temperature that comes in is not 100 degrees Celsius, which might break our freezer. It's definitely going to melt it down, but it's going to make sure that it is within an expected range, I don't know, -5 to -20 degrees centigrade. And obviously your cloud is still going to do that as well. It's not like you can send the same command. So I haven't shown it here, but your cloud is also going to do the range checking, but your fridge is also going to do that again, which is that design in depth. If your cloud is compromised, your fridge is still going to remain operational. The next topic on the list is third-party dependencies. And having a tool, unfortunately, is not enough. I know I said that this topic is largely covered by tools, but just having a tool is not enough. The tool is going to give you the SBOMs. And everybody nowadays is talking about SBOMs, which is the software bill of materials or bill of materials. But then just having that is not enough for real security, at least. You might be able to get away with it from a compliance perspective, but from a real security perspective, what you need to have in place is a formal process for dependency approval and dependency management. It's not good enough just to have an SBOM with literally everything out there in your SBOM. It is a good idea to have a minimum set of components in your SBOM. And to do that, you will have to have more deliberate and dedicated approach to dependencies, and more specifically have a formal process for approving dependencies. And then clearly you do need to evaluate dependencies for vulnerabilities. This is where your tool comes in. You cannot do this manually. In addition to that, if you find a vulnerability in your dependency, you have to report that to the relevant upstream maintainers. And maybe Lara, you can elaborate on this. I know what this topic means in the domain of security, but then from the CRA perspective, if I find a vulnerability in an open source component that I'm using, what happens from that point on?
This is Article 13.6. So basically, if you're a manufacturer and you embedded or make use of open source components and you find a vulnerability, first you have to let them know, the open source steward. And if you're able to, you have to fix the vulnerability and share the patch with them. So one of the effects of the CRA that we haven't discussed as much in the episodes is basically open source stewards. So the maintainers of these, of open source components or applications, they're going to have to interact more with manufacturers and manufacturers with them. So you have to have internal organizational measures in place to be able, when you find a vulnerability or when you patch it, you have to know the component that this patch is going to affect. Who does it belong to? Is it mine or is it someone else's? If it's someone else's, is it an open source component or is something that I contracted, something that I bought? So you have to interact with these entities in the supply chain, regardless of whether they're open source or not. And this is going to change the security realm a lot. At least this is what we're seeing in the horizon.
And here is what good looks like for Codific. We have an actually approved list of dependencies. So it is sort of the opposite of generating an SBOM from our product. We have actually a list of dependencies that everyone is allowed to use. And that's it. You cannot add a new dependency. To do that, you need to pass through a specific approval process, which helps us have sort of a minimum set of dependencies, and everybody knows there is a clear list of these are all dependencies that we're using throughout all our products, and it's not just one product. And adding a new item to that dependency list requires a formal process to pass through. Clearly, we have a number of vendors that we trust by default. So let's say Google, we're going to trust any dependency that is coming from Google. So they are sort of automatically approved and they are still put on that list. For dependencies that are not coming from these trusted vendors, we need broader consensus when it comes to approving these dependencies. And then for some dependencies, we think these are very critical. They bring in a larger attack surface to our product. So we are going to scan these dependencies themselves with a SaaS tool, AI tool, or maybe even run a semi-manual pen testing. One of these dependencies, for instance, is Finder, which is a file upload plugin. The risk that comes with this dependency is just higher than with many other dependencies. This is why we're going to pay more attention to this specific dependency. The next topic we have on our list is configuration hardening. And as I've mentioned, this is somewhat an easier topic to tackle. Configuration hardening is an issue because as a vendor, we don't like to have a hardened configuration. It might sound ridiculous, but we want our customers to have the plug and play. They plug the device, it works. It has a default password, admin, everybody knows. Nobody gets hampered with security. Unfortunately, in a modern world that has caused many headaches, many issues, this is why secure by default, that is the buzzword for configuration hardening, you need to ship your product completely hardened. You need to make sure you have no open ports, no debug files, no verbose logging, and so on and so forth. And as I've mentioned, luckily we have a lot of tools to help us out. But then on the first place, what good looks like for this topic, first of all, you need to know all your components. For our smart fridge, that could be, for instance, the embedded Linux operating system, the message queue telemetry transport client, NFC reader, and a serial interface. This would be all the components. And then for each of these components, you have to have a hardening baseline. You have to have a specification that says, okay, this is how you need to configure each of these components. You might say for our Linux OS, no SSH and Telnet should be available. No ports should be open. You should not have a universal serial communication enabled when we are shipping this to production. And also tools can help us with making sure that these baselines are correctly implemented. In a way, you're going to run the tool against the fridge that is ready to go for production or pre-packaged to make sure that no open ports are there. It's just going to scan and then the fridge is ready to go out.
I think, and correct me if I'm wrong, but theoretically it could happen that the hardening baseline for two different components, it conflicts given the way you want to use the product. And what do you do then?
Once you see there is a conflict, you will need to solve that conflict in one of the two baselines in a way. You have owners for these baselines. By the way, somebody has to take responsibility for each baseline. If it's the same person for the conflicting baselines, that person could make sure that the conflict is solved. But then the solution has to be taking into account the risk. And if they don't know what to do, they will have to go back to other teams that are doing risk assessment, that are doing threat modeling, to help them out to resolve that conflict. But in a way, the baselines at the end of the day have to be pretty clear. Okay, these are the settings you need to put. And with those settings, the product is going to work in the most securely configured way.
And this would amount to security by default?
This is my understanding of what security by default means, because we are no longer shipping our product where security is a sort of an optional button we need to click, but then it comes with security as a default setting. All right, let's try to recap this episode. The key message here is that you won't comply with the CRA by buying a tool when it comes to the technical requirements, technical security requirements. The tools are sort of the enablers of a reactive approach. We're going to run a tool and see what's wrong. Then you're going to end up drowning in vulnerability reports. You actually need something more systematic as an approach to start with risk, which we talked about in the last episode. And once you know where your risk is, once you can draw that risk function, I would say, you have to look into requirements, security requirements and architecture. And honestly, no tool will really help you there. Then you need to make sure that your software dependencies are well managed, and tooling is essential there. If you can do requirements and architecture without any tools, you cannot do software dependencies without any tool. You do need tooling there, but tooling is not everything. It's going to be helping you out, but then you still need the formal process and the formal deliberate approach to managing these dependencies, staying on top of them. And then we covered the topic of hardening, configuration hardening, where tools can help you a lot. And then this is typically a topic which is better and easier managed and more understood throughout the industry. As a next step, we would invite you to test our SAMI tool. You can do an assessment against our CRA framework. You can even generate an assessment from the OWASP SAM framework, which is the industry standard framework for application security management. And then you can identify your gaps that are clear gaps on your way to CRA compliance. You can plan improvements to address these gaps. You can even generate compliance documentation for the CRA, which is going to be handled in the last 5th episode of this series. Thank you for tuning in. Make sure, if you like this episode, to click the like button and the subscribe button to our channel. If you have any questions, put them in the comment section. Happy to address them. Happy to hear any feedback, and see you in the next episode.